Exciting to come your way once again. My name is Nana Awedu, and you can call me Nana. Let's journey through this wonderful lesson in core mathematics. In our previous lesson, we've considered some examples on the exterior angle of a triangle. Remember to share this video, like this video, comment at the comment section if you find anything interesting, and don't forget to click on the notification bell and subscribe to my YouTube channel so that you can get all videos on time. In this lesson, we want to consider the interior angle of a regular polygon. Now, let's consider what a polygon is. So basically, when we look at a polygon, we are considering a close two-dimensional figure. So I believe in your previous lessons in the JHS, you've considered dimensional figures or two-dimensional figures. And we know that for two-dimensional figures, they have straight sides and they are flat, right? So for instance, if I draw this, it's in two-dimensional. If I give it a form where it has a form here, then it becomes a three-dimensional figure. So this is more of a 3D. But then when I have just a side, then this is a two-dimensional figure. And we mentioned that the line segments of the polygons are called sides, right? So the line segments are sides, and they are joined at each point as the vertex, right? So they are vertices. Now, polygons have at least three sides because you can have two sides as a polygon. So it begins from three sides, where the three sides will basically be a triangle. And then you can have four sides, where the four sides can be more of a quadrilateral and the like. So let's look at some different types of polygons. So we have a triangle which has three sides basically. We have a quadrilateral that have four sides. We have a pentagon and it has five sides. We have a hexagon, right? Hex means six. So hexagon means it has six sides. Heptagon means seven sides. Octagon means eight, right? Nonagon means that it has nine sides. And decagon means that it has 10 sides. Now remember that we can have regular polygons. So we can have what we call regular polygons. And when we talk of regular polygons, we are looking at those type of polygons whose sides are equal. So let's assume that with this hexagon, all the sides are equal, then we can say that it's a regular polygon. If not, then it's just a polygon, right? So now let's consider how we can find the interior angle of a regular polygon. So I have some shapes here, right? First and foremost, let's consider this shape. We realize that a shape consists of four sides. So from A to B to C to D, it has sides 1, 2, 3, and 4, right? So it has sides 1, 2, 3, and 4, right? So there is side 3, that is side 4. So that implies that we can say that our n, which represents our number of sides, is 4. Right? So we are dividing them into triangles because we are familiar with the sum of interior angles of a triangle, right? So when we take the sum of interior angles of a triangle, we know that they sum up to what? 180 degrees. So that will be our basis for being able to determine what the sum of an interior angle of a regular polygon is. So we see that in this, for instance, in the case of this diagram, for instance, there are two triangles. So you can see triangle A and triangle B, right? And each of them will have a sum of interior angle to be 180 degrees. This will also be 180 degrees, right? So it means that if the size is 4, which is a quadrilateral, then the sum of interior angles of all of it will be 2 multiplied by 180 degrees. And that will give us 360 degrees. Now we see a very clear relationship between the n and the formula for finding the sum here, right? So let's look at the second one so that we can be able to establish that relationship, right? So for instance here, if we consider the sides, we'll see that it has one side here, it has 2, it has 3, it has 4, and it has 5. So we can see that in this, the n, which represents the number of sides, is 5, right? So it means that for this, for instance, is a pentagon. This is a quadrilateral. Now, how many triangles do we have here? So in this case, we have triangle A, we have triangle B, we have triangle C. And each of them have 180 degrees as a sum of the interior angle of a triangle, right? 180 degrees, 180 degrees, right? So now, what will be the sum of everything which is a pentagon? It means that will give us 3 of them. 1, 2, 3. So 3 multiplied by 180 degrees. And that should give us 540 degrees. So let's look at something. When we consider the first one, when n is 4, the number that works here is 2. It means that the number have been subtracted by 2, right? There's been 2 subtracted from the 4 to give us a 2 here. Look at here, when n is 5, the number here that multiplies by the 180 is 3. So here 2 with the 5, there have been 2 subtracted from the 5 to give us a 3, in order to be able to give us the sum as what? 540 degrees. Now let's consider another example. So here we have another size here, right, where we see that the size here, we can label them as 1, we have 2, we have 3, we have 4, we have 5, and then we have 6, right? Now, how many triangles does the hexagon, which is a 6-sided figure, have? So we can see that it has sides of the triangle A, B, C, and D, right? So if n is equal to 6, it means that each one of them will be 180 degrees, 180 degrees, 180 degrees, and 180 degrees. So it means that the sum of interior angle, right, when n is equal to 6, it means that it's going to be 4. 1, 2, 3, 4, right? Multiplied by 180 degrees. And that should give us 720 degrees. So we see a pattern. In all the things that we have looked at, we see a pattern. And let's consider that pattern. So when we look at it, we see that the pattern here is that when we consider the size, so for instance with a triangle, we see that the size n is equal to 3, right? So n is equal to 3. We see that the formula for finding the interior angle is m minus 2 multiplied by 180. Because if n is 3, it will be 3 minus 2 multiplied by 180, which is 1 multiplied by 180, right? And that gives us 180, as we see here, right? Let's try probably for the quadrilateral 4. So it means that it is 4 minus 2 multiplied by 180. As we've looked at intuitively when we're looking at all the shapes, right? So 4 minus 2 multiplied by 180 gives us 2 multiplied by 180, and that gives us 360 degrees. So when we look at it on and on and on and on, it means that any polygon, if you know the side, if you want to find the sum of interior angle of a polygon, it must be equal to m minus 2 multiplied by 180 degrees, right? So this is a general formula for finding the sum of the interior angle of a regular polygon. And we've gone through the process intuitively to be able to look at it from the shape of the quadrilateral to looking at the pentagon to looking at the hexagon, and now looking at it generally when we consider these tables to be able to say that for the sum of interior angle of a regular polygon, it is n minus 2 multiplied by 180. So in this lesson, we have basically looked at how we can determine the sum of the interior angle of a regular polygon. And we've used the different types of polygons to be able to generalize and come out with the formula n minus 2 multiplied by 180 to find the sum of interior angles of a polygon. In our next lesson, we want to solve some questions on the interior angle of a polygon. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.